Friends, very good morning to everyone. We were dealing with the continuous flow reactors. We know that the success secret for continuous flow reactors is the efficient heat mass transfer, which is governed by Fourier's law of heat transfer. The efficient mixing along with efficient heat transfer gives the success to the continuous flow reactions. Today's subject of discussion is the types of reactions that can be carried out by continuous flow system. A number of varieties of reactions have been reported in the literature, and these reactions can be classified into four types. The first type is one reaction in which all the reagents and reactants flow through the reactor, and at the end the product is collected. The second type is one in which one of the reactant is supported onto the solid support, and this reactant is confined to reactor, and the substrate along with the reagents pass through this supported reactant, and at the end the product is collected. The type 3 is the reaction in which a homogeneous catalyst flows together with the reactants through the reactor, and at the end the separation of the product from the catalyst and the byproducts are done, and then the product is taken out. The fourth type is one reaction in which the catalyst is immobilized onto the solid support, and the reactants pass over on this solid support, and during this course the reaction gets completed and the product is taken out. As the catalyst is supported or immobilized onto the solid support, the separation of the product from the catalyst can be avoided. These are the four types of reactions which can be carried out by continuous flow systems. Let us see few of the examples of synthesis of active pharmaceutical ingredients by using continuous flow system. This is the slide which shows the continuous flow synthesis of diphenhydramine hydrochloride. Diphenhydramine hydrochloride is an antihistaminic drug which has a lot of market. The demand or requirement is 100 tons per year all over the world. This synthesis has been achieved by continuous flow system in a very efficient manner. To synthesize diphenhydramine hydrochloride, the diphenylmethane and diaminoethanol are mixed together without any solvent, and then they are pumped into the PFA tube reactor. PFA stands for perfluoroalkoxy, which is a Teflon reactor, a reactor made up with Teflon. Teflon has very high chemical resistance along with heat resistance, and it do not have sticking property. This makes it very much viable for the reactions to occur. This tube has a diameter of 0.5 millimeter, and it is heated at 175 degrees centigrade. The temperature which is above the boiling point of diaminoethanol. During the passage of these reactants through this perfluoroalkoxy tube reactor at 175 degrees centigrade, the reaction completes in 16 minutes. The residence time for the reaction is 16 minutes. The OH lone pair of electrons attacks on the electron deficient carbon of diphenylmethane derivative, and chlorine gets kicked off, which separates as HCl, a byproduct. Then, to neutralize this HCl, it is treated with 3 molar solution of sodium hydroxide in water, and the HCl is neutralized, which is mixed with hexane after quenching the reaction, and the diphenhydramine which is formed is extracted into the hexane which is added, and this is fed into the membrane receptor which is in line with the continuous flow system. The membrane separator separates the aqueous layer and removes the aqueous waste, and the organic layer was treated with 5 molar hydrochloric acid solution in isopropyl alcohol. The diphenhydramine reacts with HCl to give diphenhydramine hydrochloride salt, which precipitates, which can be filtered, dried, and used for the purpose. The overall yield is 90%, and the rate of formation of diphenhydramine hydrochloride is 2.4 grams per hour. The beauty is the reaction mixture is fed into a PFA tube of 720 microliter capacity. It is fed slowly into this in a very small volume reactor, and as it is having very small diameter and small volume passes through it, the efficient synthesis occurs in a very small time, having it enhances the reaction rate. This is one of the first examples for the synthesis of diphenhydramine hydrochloride by continuous flow system. Another example we can take, which discusses the synthesis of rufinamide by continuous flow system. Rufinamide is an anti-epileptic drug. It is a triazole derivative. Triazole derivatives are achieved by 1,3-dipolar cycloaddition of azides with alkynes. And this belongs to the category of click reactions. Click reactions are rapid reactions, or the reactions which occur rapidly at very benign temperatures and with excellent yields. However, it has its own limitations, as the azides which are used are prone to detonation. On very slight exposure to heat, pressure or light, it explodes violently. Further, these organic azides, during the process of reaction, it generates hydrozoic acid, which is also explosive. Thus, for the industrial level of preparation, it is very much limited because of the safety and regulatory concern. Hence, flow chemistry is the answer for handling this type of hazardous reactions, handling hazardous intermediates. The 2,6-dichlorobenzyl azide has been prepared by treating 2,6-difluorobenzyl bromide dissolved in DMSO solution with sodium azide dissolved in dimethyl sulfoxide mixed and fed into the 40 microliter PFA microreactor. At room temperature, the reaction occurred within 1 minute. The residence time is 1 minute. The product formed within a minute. Parallelly, methyl propionate was treated with ammonia solution without any solvent. The methyl propionate was mixed with ammonia and fed into 57 microliter capacity PFA microreactor at 0 degree centigrade, and the reaction occurred within 5 minutes. The residence time is 5 minutes, and propionate amide, which is highly reactive and highly unstable intermediate, is formed in 95% yield. The azides or the propionate amide which are formed are not purified, are not isolated and separated. These two are mixed in a mixer and then fed into the copper tube of 431 microliter capacity. The azide and the propionate amide underwent 1,3-dipolar cycloaddition at 110 degrees centigrade and 100 pounds per square inch of pressure, and the reaction completed within 6 minutes of residence time. The back pressure equipment do not allow the mixing of the product found with the reactant. And the overall yield achieved is 92%. This is an example for efficient handling of hazardous substances. The beauty of this flow system is that the capacity of the reactor used is in microliters, and as they are produced in small quantities continuously, and the produced azides are utilized immediately, they are large produced in large quantities at a time. That's why making it safe, and hence overcoming the regulatory issues. The one reaction which is very difficult to be carried out can be achieved by continuous flow system in a safe and efficient manner. There are other active pharmaceutical ingredients prepared or produced by using continuous flow system. Those will be the subject of discussion in the coming presentations. Till then, have a nice day. Thank you.